Okay, this is concept 56. This one's only half new content. It starts with law of sines versus law of cosines, and all this really means is when presented a triangle, how do you know which one to use so that you can solve for the missing side or angles, whatever it is that you're doing, right? So for law of sines, here's our formula here. So you use, when do you use law of sines? And I'm pulling this information from our previous notes, right? If you remember in the beginning, they tell us when to use law of sines and when to use law of cosines, right? What type of triangles we have. You use law of sines when you're given two angles and one side, and you recall from geometry, we call these angles side angle and angle side. The other one was when you're given two sides and one angle, and we call this one side angle. When do you use, oh sorry about that, when do you use law of cosines? You use this one when you have two sides and one angle. We call this one side angle side. And then when you were given all three sides, this one was side. So it says indicate the law, then find each missing measure to the nearest 10. So the first one, I have three sides, right? Well, I'm given two sides. I need to find the third, and I'm given one angle here, right? So side angle side is what's given. So I'm using law of cosines right here, right? Two sides, an angle, side angle side, side angle side. So this one is cosine. So x squared is equal to 9 squared plus 19 squared minus 2 times 9 times 19 times cosine of 39 degrees. So you get x squared is equal to 9 squared plus 19 squared. Put that in your calculator. You're going to get 442 minus, then 2 times 9 times 19. You're going to get 342 times the cosine of 39. So then right, input all this, put all this in your calculator. You're going to get that x squared is equal to 176.2161, and then take the square root of both sides. You're going to get that x is equal to 13.3. That's it. So the next one, I'm given two angles, one side in between them, and I need to find the other side, right? So angle side angle. So this is going to be law of sines. So check sines, and I have the sine of 54 over x is equal to, and then this is one of those triangles where I'm going to need to find that other angle, right? So thankfully 54/77, I just subtract those from 180, and I get that this one here is 49. So then the sine of, I could do the sine of 49, that's equal to the sine of 49 over 30. And then I'm going to get let's see, if I multiply both sides, I'll show the steps. Let's see, so 30 times sine of 54, I multiply both sides by 30 there, that's equal to x times sine of 49. That's when I multiply both sides by x. So then I get that x is equal to 30 times sine of 54 over sine of 49. And then when you put all that in your calculator, you're going to get that x is equal to 32.2. Okay. Next one. It's going to be hard to fit all this. I'm going to just be going back and forth. So, okay. Number 3. I'm given two sides and an angle here, and in the order would be, right, it would be side, side, angle. So which one is like side, side, angle, right? If we go to the top here, it would be right here, right, side, side, angle. So I could use law of sines here. So check sines, and I have the sine of x to side 8. So the sine of x to 8 is equal to the sine of 112 degrees over 18. So I get 18 times the sine of x is equal to 8 times the sine of 112, and then I'll get that the sine of x is equal to 8 times sine of 112 over 18, and then put this in your calculator here. You're going to get that the sine of x is equal to 0.4121. So you got to take the inverse sine, and when you take the inverse sine, you're going to get that x is equal to 24.3, and then recall that you have to check your solutions, right? So subtract this from 180. The other solution you're going to get is 155.7 degrees, and 155 plus 112 is clearly above 180, so then you know that's not a solution. So then you got this here. A question might be, do you need to show both? I would say yes, because if you don't have this one here, I can assume that you just forgot to check for the other solution. So yes, I'm gonna say you do need to show both, even if one of them is clearly not gonna work. Alright, next one. I have side, side, angle's not given though, right? But side, side, side. So all three sides are given. So what is this? Side, side, side is going to be law of cosines. So check cosines, and I'm going to use the side opposite to the angle I got to find, right? So 7 squared is equal to 6 squared plus 5 squared minus 2 times 6 times 5 times cosine of x. So I get 49 is equal to 25 plus 36, you get 61, minus 6 times 5 times 2, you get 60 times cosine of x. Subtract, you're going to get negative 12 is equal to negative 60 times cosine of x. Divide, you're going to get, so divide both sides by negative 60, you're going to get 0.2 is equal to cosine x. So then x is equal to the cosine of inverse 0.2, and then in your calculators, that's going to give you x is equal to 78.5 degrees. And that's it. Okay, next page. So just recall some terminology. What does it mean to solve triangles? If you recall from last year's SOHCAHTOA, right? To solve a triangle means to find all missing side and angle measures of a triangle. Use the information given to solve each triangle, round all answers to the nearest tenth. So, you know me, right? We're going to draw them out. So, this one here says triangle ABC. So, ABC. Says the measure of angle A is 47 degrees. So I have 47 there. The measure of angle B is 52, and then AC is 13. So maybe the thing we could do just right off the bat is solve for this guy here, right? Because you know they all add up to 180. So you could do 180 minus 47 minus 52, and if you do that, you're going to get that angle C is 81. So that's that, and there's really nothing else I can go for as far as, like, you know, easy computation. So I have to use law of sines, law of cosines going from here. So I have all three angles given. I have one side given. I can say, you know, angle, side, angle. So I could use law of sines here. So sine of 52 over 13, I want to use that one, right, because that's the only side I'm given. That I can use that now to do sine of 47, for example, right, to find, we'll call this guy x. So x, and you're going to get that x times, let me see, you're going to get x times sine of 52 is equal to 13 times sine of 47, and then x is equal to 13 times sine of 47 over sine of 52. When you put that in your calculator, you're going to get that x is equal to 12.1. So then CB is, might as well label these already. CB or BC is 12.1, so 12.1 here. We found angle C to be 81 as well. So in the other one, you can use, right, so we found this one to be 12.1. You can use the one we just found, or you can use the one that we used in the first one. So like, in other words, sine of 52 over 13 is this time equal to sine of 81 over, and we'll call this guy y. Again, you could have used sine of 47 over 12.1 is equal to sine of 81 over y. That it should give you the same value, and again, you can test it and you'll see. Anyway, so it's y times sine of 52 is equal to 13 times sine of 81. You'll get y is equal to 13 times sine of 81 over sine of 52, and then in your calculators this will give you 16.3. so this guy here is 16.3, and then here's your final answer. So there, we just solved this triangle. We found all sides and all angle measures. Number 6, we have triangle XYZ. So XYZ. It says XY is 29, YZ is 22, and XZ is 21. So this time I'm given only the side lengths, right? So this is side, side, side. So I'm going to use law of cosines to be able to find my first angle. So use I mean, if we start and say let's find angle X. I'm going to call that one little x, I guess. So that's my angle. So 22, right, the side opposite to it, 22 squared is equal to 21 squared plus 29 squared minus 2 times 21 times 29 times cosine of x. 22 squared, and you get 484. That's equal to 21 squared plus 29 squared. You're going to get 1282 minus 1218 cosine x. Subtract from both sides. 1282, you're going to get negative 798 is equal to negative 1218 cosine of x. And then you divide both sides by negative 1218, you're going to get 49. And you get this, you're going to get a decimal. Let me see. So 0.27 divided by 12. I'm getting 0.6551. That's equal to cosine of x. So then you take the inverse cosine of negative 1 of 0.6551. That's equal to x. When you do that in your calculator, you're going to get whoops, sorry, this is one that I made a mistake on my side notes here, so that's why it's taking longer. You're gonna get 49.1. So x is equal to 49.1. Let me use a different color here because it's gonna start to get crowded. So this guy here is 49.1 degrees. There. Okay, so now that we have one angle, I mean, we could keep using law of cosines, we could, but personally I prefer to use law of sines, especially now that we can use it, seeing as how we found one angle, right? So I could do sine of 49.1 over 22 is equal to, you know, little z over sine of 29, and then again for these two. So I'm running out of space here, so let's see. Sine of 49.1 over 22 is equal to, and then you just take any other, let's say this one, little y. So sine of little y over 21, and then so I get 21 times sine of 49.1. You guys notice I sometimes leave out the parentheses, so please use the parentheses. It's a good habit of doing that, of knowing what's within the sine function. I know I don't always do it, I didn't do it here, but just, you know, it's a good habit to always do it. Anyway, so 21 times sine of 49.1 is equal to 22 times the sine of y. So then I get sine of y is equal to 21 times the sine of 49.1 over sine, no, over 22. So I'm getting sine of y is equal to, I did a mistake in this one too in my side notes, so this is going to take a few seconds here. Let's see. I'm getting 0.7215, and then you take the inverse sine. I'm running out of space, so I'm just not going to write it out anymore. So inverse sines of 0.7215, you're going to get that y is equal to 46.2. So y is 46.2 degrees. So I can label this one now 46.2 degrees. Now, be aware, right? Stay woke. Don't go and use law of sines again to find the last angle, because you don't need to. You could, but you don't need to, right? They add up to 180 because it's a triangle, so just subtract those two from 180 degrees. 180 minus 49.1 minus 46.2, you're gonna get 84.7. 84.7 degrees. So that's angle Z. And we just solved this triangle. Now we have all the sides and all the angles. Number 7, triangle DEF. DEF. It says angle F is 72 degrees. 72 degrees there. DE is 15. And EF is 12. So I have side angle, right? So which one can I use? Side angle, it's gonna be law of sines. So so here the sine of 72 over 15 is equal to, and then we could just call the side opposite to 12, right? We could just call angle dx for now. So the sine of x over 12, I'm gonna skip some of the steps here. for the sake of conserving space, as you saw the last one got really tight. So sine of x is equal to 12 times sine of 72 over 15. If you put this in your calculators, you're going to get that the sine of x is equal to 0.7608, and then take the inverse sine here, so the sine inverse of 0.7608, that's equal to x, and you're going to find that x is equal to 49.5 degrees. So this guy here is 49.5 degrees. For the last one, I mean, you could just subtract, right, from 180 degrees, and you could find the last angle. But I mean, it looks like that's not what they're asking for, even though I mean, I guess solving all triangles, it is to find everything, so we could just do it for fun. But anyway, let me see, angle D here, we found it to be 49.5. We need to find angle E. Oh, it is asking for it, sorry, I didn't even realize there. So you subtract 180 minus 72 minus 49.5, and when you do that, you're going to get that angle E is 58.5 degrees. And then so let's label it 58.5 degrees. And then from here you could use law of sines again, and you could find the side opposite to it. We could call this one for now y, so df is y. Sine of 72 over 15 is equal to the sine of 58.5, right, because that's the one opposite to y, over y. So I'm getting okay, fine, multiply both sides by y, multiply both sides by 15, you're gonna get y times sine of 72 is equal to 15 times sine of 58.5 degrees. So y is equal to 15 times sine of 58.5 over sine of 72. And then when you put that in your calculators, you're going to get that the y value is 13.4. So that's down there. So 13.4 there. And that's it. We found all the values for this triangle. Number 8, I have triangle RST. Measure of angle R is 55 degrees, RS is 17, and RT is 9. Okay, so RS, this is S, RST, angle R is 55, RS is 17, and RT is 9. So I have side, angle, side, right? Side, angle, side. So which one should I use? If I go here, which one is side, angle, side? It's right here. It's law of cosines. So I should approach this problem with law of cosines. So to find this side here, call it x, and then of course I'm giving the side, the angle opposite to it. I have x squared is equal to 9 squared plus 17 squared minus 2 times 9 times 17 times the cosine of 55. 9 squared plus 17 squared, you're going to get, let's see, x squared is equal to 370 minus 2 times 9 times 17 times cosine of 55. So step at a time. I see 2 times 19, 18, 18 times 17, you get minus 306 times cosine of 55, and then compute this, you're going to get x squared is equal to 194.4856, and then take the square root of both sides. You're going to get that x is equal to 13.9. So then that means ST is 13.9. There. Next thing, let's see. So we're missing two angles now. I can, let's see, I have all three sides given. I can approach again with law of cosines technically, right? So that would be one way. I would say that the easier and shorter or faster way might be just to use law of sines. So you know, you could take the one we just found, right? Sine of 55 over 13.9. That's equal to, we'll call this guy, you know, you can take either, right? You can just solve for either. So we'll just call this one y, because we're working with a smaller number. So let's take that one. So then the sine of y over 9. So sine of y is equal to 9 times sine of 55 over, whoops, 13.9. That's when I multiply both sides by 9. And then I guess sine of y is equal to, did I mess this up? No, I didn't. So sine of y is equal to, oh, I did mess this up. Okay, let's see. So I had another mistake, guys. Apologize. Divided by 13.9. It's actually really late right now while I'm filming this video. So 0.5304. Take the inverse sine. And you're going to get, yeah, if you round, you're going to get that y is equal to 32 degrees. So this guy here is 32 degrees. And remember, you don't have to do any more longer work, right? You could just subtract from 180 degrees to find the last angle, angle T. And if you do that, 180 minus 32 minus 55, you're gonna get 93. So that one here is 93 degrees. Okay, so we're about halfway through this concept. I know it's been long. Maybe pause if you're tired of hearing my voice, and then go and do the homework assignment for the problems that you're able to do so far. Again, so a lot of this was just review. It's just more just deciding which one, which law you're going to use, sine or cosine. The next part, let's see. The next part of this concept is area of triangles. Okay, so we have this here. So this is still the same concept. So it's concept 56 continued, maybe, in a sense, part 2, whatever it is. And we're now going to, I really like this one because we're going to connect trig functions to the area of triangles. And you'll see how it falls in really neat. So what is the formula of the area of a triangle? Area is equal to 1/2 base times height. Okay, we know this, right? We've been working for this for years now. We also know that the sine of C, okay, and I'm looking at sine of C, I'm looking at this right triangle that's right here. Okay, this one right here. Sine of C, opposite of our hypotenuse, so H is my height of this triangle, not to confuse the terminology or the labeling of this triangle, okay? Sine of C is the height over the hypotenuse A in this case. So H, the height, over A, the hypotenuse, okay? Therefore H, if I'm solving for H here, H is equal to, if I multiply both sides by A, I get A times the sine of C. So that's what the height of the triangle is in terms of a trig function. So when you substitute this back into this formula, you're going to get that the area of a triangle is equal to 1/2, and then when I plug this in for h here, right, I get b times a times sine c, but for the sake of order variables, I get ab, okay, ab sine of c. And there you go. This formula relates the area of triangles with trig functions, okay, sine of c. Just notice one quick thing we got to note: this is the sine of angle c, okay. A, B are part of the formula, so you're using the angle opposite to the side that's not in the formula, okay. So what do I mean by that? Look at this first example. I got two sides given, and here's my angle, okay. These two sides are A and B, okay, because C is not given, but I am taking the sine of angle C, which would be opposite to the missing side, okay. So this one here, so plug it in. So A is equal to 1/2, okay, 15 times 12 times the sine of 1/10, and then you're gonna get so 15 times 12 divided by 2, you're gonna get area is equal to 90 times the sine of 1/10, and then put that in your calculator. You're gonna get, and don't forget your units of measurement as well. You're gonna area is 84.6 centimeters squared. Whoops, got sloppy there. Okay, so that's it. That's how these problems are gonna work. Okay, so you just plug it into the formula. So next one, this triangle is slightly different, right? I'm giving all three sides here, but you're still gonna use your as according to the formula. So sine of 72, if you're using this angle, if this is sine C, then this is side C, so you're not using this in your formula, you're using A and B, so 6 and 8. So the area for this triangle is 1/2 times 6 times 8 times the sine of 72. 6 times 8 divided by 2, you're going to get that the area is equal to 24 times the sine of 72. And then in your calculators, you're going to get that this is 22.8 meters squared. The third one, same thing. I'm not using 10.3 because that is not A or B. That would be C. So area is equal to 1/2 times 23.5 times 24 times the sine of 25. So then area is equal to, do that in your calculator, 23.5 times 24 divided by 2, and when you do that, you're going to get 282 times the sine of 25. Do that in your calculator, you're going to get that the area is equal to 119.2, and this time it's inches squared. Please do not forget your units of measurement, okay? You will lose points in the test if you don't have your units of measurement. Okay, so number 4, I'm given two angles, right? I can, let's see, the approach here would be, I have two given sides and two angles. So how do I find the area here? These angles are not the ones that are useful to me, right? Because I need to get the angle that is opposite to the side C that I wouldn't be using. So these here are A and B, so these are big angles A and B, or A and B here. So, but since these two are given, I can solve for the third angle. So 180 minus 81 minus 43, I'm going to get 56. So that one there is 56. And that's it, really, that's all I need. So area is equal to 1/2 these two sides, right, 34 times 49.2 times the sine of the angle you found, 56. 34 times 49.2. You're gonna get the area and then divide by 2, right? You're gonna get 836.4 times the sine, 56, and then put that in your calculator. You're gonna get that the area is equal to 693.4 feet squared. Last one in this page, similar to number 4, right? Because of the two sides given, those are opposite to angles that are given, so I need to find the one that isn't. 180 minus 24 minus 31. I'm gonna get 125. So that angle there is 125, and now I can take that angle and those two sides. So area is equal to 1/2 times 14 times 17 times the sine of 125. 17 times 4, 14. Divide by 2, you get the area is equal to 119 times the sine of 125, and then in your calculators you're gonna get area is equal to 97.5 meters. This is meters squared. Okay, so the next page right here says, using the laws of sines and law of cosines, in order to find the area you will need two sides and then in order to find the area you will need two sides and an included angle, side, in other words. So this one puts it all together. You're going to use law of sines, law of cosines, and then once you find the necessary information, you can plug into your formula for area, and then you find the area. Basically, that's all. That's what we're doing in this page. So what I'm going to do is, let's see how long this lesson can drag out. Eventually, I think I won't do all of them on this page. I'll probably just do 3 of them. So I'll do the first one, number 6, number 9, and number 10, I think. And we'll leave 7 and 8 for do now problems. So be sure to just do it. That way you have a head start later. Okay, so this first triangle, I have an angle and two sides. So this one, right, would be, and if you recall, let's see, where are my papers? Which one? There's two sides and an angle, right? Side angle. It would be this one right here. So this is law of sines. So I can use law of sines here. So I would take, let's just label this one for now x. So sine of 93 over 12 is equal to sine of x over 7. And then I get sine of x is equal to 7 times sine of 93 over 12. And then if you do this in your calculators, you're going to get that then you get sine of x is equal to 0.5825. Then you would take the inverse sine. I'm running out of space here, so you would take the inverse sine, and you'll get that x is equal to 35.6 degrees. Don't forget to check if there's two possible solutions. Okay, so if you subtract from 180, you're going to get 144.4 degrees. Okay, and you'll see that based on the one they give me, 93 and 144.4, you cannot have the second one, so that's not a solution. So this one here is 35.6. So use red, that way it's doesn't look too crowded. Let's see. So okay, so to find the last angle, I could say let's just use angle Y. Now why am I finding the last angle? Let me pause here. Okay, because to find the area, right, if you remember the formula for the area, you want to use that angle that is not opposite to one of the sides you're using. So I need to use this angle here, okay, because I have these two sides here. So I can subtract 180, I could do 180 minus 93 minus 35.6 to find, let's label it angle Y. So fine, let's just show that angle Y is equal to 180 minus 93 plus 35.6. You're gonna get that angle Y is equal to 51.4. So this guy here is 51.4. So now I can plug into my formula. I get the area is equal to 1/2 times 7 times 12 times the sine of the one we just found, right? So 51.4. So area is equal to 7 times 12 divided by 2. You're gonna get, what's that, 84? Yeah, it's 84. 42. 42 times sine 51.4, and then when you put that in your calculator, you're gonna get that the area is equal to 32.8 feet squared. And then that's how we found the area here. Okay. All right. Let's do 7. So I have 2 angles given and 1 side given. So seeing as how my area formula requires me to use 2 sides, then I should definitely find 1 more side, right? Because it's just something I'm gonna need. And then just to kind of like tailor this to doing less work would be, I'm given 2 angles already, so might as well find 1 side that would be in between one of the angles and then go from there. Then I'd be able to plug into the formula. So let me see, I have angle side angle, right? Angle side angle, if you recall from the other sheet here, anymore, but you would use, it's law of sines. It's law of sines. So you would use sine of let me see. Actually, wait, I have to find this angle right here, right? So 180 minus 28 minus 114, you're gonna get that this angle is 38. Yeah, 38 degrees. Okay, now I can do sine. So sine of 38 over 20, that's equal to sine of, I'm going to use, let's say for my formula, when I go and find the area, I'm going to use this angle. So I need to find this side here, right? Because I need that side and that side. So I'm going to use sine of 28 over, and then we'll call this guy x. So x. So I get x. I'm going to skip ahead here, multiply both sides by x, both sides by 20. I'm getting 20 times sine of 28 over sine of 38. And then in your calculators, if you put that, you're going to get x is equal to you're going to get 15.3 inches. So right here, 15.3 inches. So now I can plug into my area formula. So 1/2 times 15.3 times 20 times the sine of 114. That's going to give me the area of this triangle. So 15.3 times 20, you're going to get 153 times sine of 114, and you're going to get at the area is equal to 139.8 inches squared. Okay, to save time in this lesson, it's already been long. Okay, I'm going to skip number 8. Go ahead and try it. This will be our do not problem you know, in the coming days, but make sure you at least try it. Okay, I'm gonna wrap this one up with 9 and 10. So 9, I'm given 3 sides, right? This one I think should hopefully be landing already. Oh, all 3 sides are given. I'm using law of cosine, so I can use law of cosines to find one angle and then go from there. And the one I should find would be one, well, because all 3 sides are given, I should find just one that is in between. I just need to take law of cosines once. Sorry, okay, I know I've been rambling. I sound like I'm rambling here. I need to take the law of cosine once to find one angle between 2 sides. So let me just randomly pick. I'm gonna go with this angle here. Okay, so if I'm trying to find this angle here, x, then I have 15 squared, law of cosines, right? 15 squared is equal to 21 squared plus 23 squared minus 2 times 21 times 23 times the cosine of x. I'm going to need to take inverse cosine at the end. So 15 squared, 225. 21 squared plus 23 squared. Do that in your calculators. You get 970 minus 2 times 21 times 23. You're going to get 966 times the cosine of x. Subtract 970 from both sides. You're going to get negative 745 is equal to negative 966 times the cosine of x. Divide both sides by negative 966. You're going to get a decimal. You're going to get 0.7712. Then you're going to need to take the inverse cosine. So the inverse cosine of 0.7712, you get x is equal to 39.5. I don't know if you guys could hear those cars, but like I said, I live close to the freeway, so, and some of these cars that pass by are like obnoxiously loud, so I apologize if you can hear them. Okay, so this angle is 39.5, so now I can plug into my formula using these 2 sides and this angle. So the area is equal to 1/2 times 21 times 23 times the cosine, no, not cosine, whoops, sine of 39.5. So put that in your calculator. 21 times 23 divided by 2. I'm gonna get area is equal to 241.5 times the sine of 39.5. You're gonna get that the area is equal to 153.6, yeah, 0.6, round to nearest 10, so millimeters squared. Okay. Last one. Again, all three sides are given. This is going to be law of cosines, and then just pick one angle that you're going to find in between two sides, and then use that for your area formula. So I'm just going to find this guy here. Okay. So I'm using the side opposite to it. So 22 squared is equal to 17 squared plus 16.5 squared minus 2 times 17 times 16.5 times cosine of x. 22 squared is 484. That's equal to 17 squared plus 16.5 squared. You're going to get you get 561.25 minus 2 times 17 times 16.5. You're going to get 561 times cosine of x. Alright, subtract 561.25 from both sides. You're going to get negative 77.25 is equal to negative 561 times cosine of x. And then you divide both sides by negative 561. You're going to get pretty small decimal. You get 0.1377 is equal to cosine of x. And then you take the inverse sine, not the inverse sine, the inverse cosine, sorry, inverse cosine, and you're going to get that x is equal to 82.1 degrees. So let's label him. Let's label him there. So then now I can plug into my area formula. 1/2 times 17 times 16.5 times the cosine. Again, I don't know why I put a cosine. I guess I'm using law of cosine. This is sine of 82.1. Oops. There you go. Yeah, so then put this in your calculator. I'm just go ahead and write it all in this time just to save time. So, and you could, right? You do 1/2 times 17 times 16.5 times sine of 82.1. You're going to get that the area is equal to 138.9 meters squared. And that's it. That's the long concept finished. And I believe this wraps up law of cosines and law of sines. Okay, that's the entire thing. It might be just, you know, longer, more tedious, if just depending how familiar you were with it. But you know, it's a lot of plugging in. I feel like it's much more easier than what we've been seeing with the first set of trig. But this is the first half of trig done in this unit. Okay, so let me know if you guys have any questions.